Okay, well, we're going to continue, and next up is Matt Vogt. Matt, it's great to be working at the same company with you.
Yeah, it's exciting.
Came from SimpliVity, and Matt's going to talk a little bit about SimpliVity. We thought this was important to include it because it was an important acquisition for HPE in the last year, and it often comes up as part of a storage conversation. It's a different option for people, and but I think it was important to include it in talking about storage options that we have at HPE. So thanks for coming.
Thanks, Calvin. And I'm going to dive a little bit into some of the deeper underpinnings of how we actually store data and write data. And so that's I actually do want to focus on that a fair bit because I know that there are a lot of technical people in the room that might be interesting. So I'm going to kind of vacillate between kind of the whole business value, the long-term strategy, the deep technical, go back to outcomes and back into a demo and Q&A throughout. We're all good with that. Cool? All right, so again, I am Matt Vogt. I'm a hybrid IT janitor for HPE SimpliVity, I think, at least today. And we're going to just kind of roll on through. So I want to start, like I said, with HPE's kind of overarching vision. And you're going to hear this from every HPE person really today. And so the broad vision is that hybrid IT is a reality, and that's kind of the future of IT from where data lives, where compute happens. That's from on-premises, out of the cloud, at the edge, services in between, all that fun stuff, right? IoT is big and exploding. And so now there's this concept of what helps us move data around, what helps us actually get to this reality. And so from a technical perspective, when everything computes, right, that's kind of a big HPE thing, everything computes. What gets data to the compute and vice versa, right? So how do we actually do data mobility? And the amount of data that we're talking about is no small thing, right? It could be small things calculated locally and then big bursts out to a cloud, out to a co-location facility, your main data center. And so one of the things I'm going to talk about today is what SimpliVity built is actually what we call the data virtualization platform. What it means is this is a way to efficiently manage and migrate and move and mobilize data. And so we're going to talk about that. So SimpliVity's broad vision. This is why HPE bought SimpliVity. We're going to talk about all that fun stuff on the left, but the idea for SimpliVity was to create not just an HCI product. That wasn't what we built. It's what we came out with our first iteration, but to really have this idea of just federated pools of stuff, meaning federated pools of compute, of storage, of backup, disaster recovery, all this in a single, what we call a federated environment, meaning everything talks to everything, everything can move everything, everything's aware of everything. And so what that allows us to do is to not just create pools of storage and compute, which is your traditional definition of hyperconvergence, but a global federated pool of resources. And whatever we mean by resources, we'll get there. And so we do it by all these, kind of the three things you see on the left are what we call our three pillars of innovation. There are three founding principles of how we actually built the technology. So guaranteed data efficiency, we'll get into that, not just from a production inline I/O experience, but what does that mean for all the cascading I/O throughout the data center, both on-prem and off-prem? Resiliency is a key component for HPE SimpliVity now as it stands as an HCI product from day one. So we'll get into that a bit, as well as management. Management is key. The whole concept behind hyperconvergence, besides what it actually converges, is what it actually does for you. And simplicity is the key, right? That's the whole reason HCI exists, is make things simple. And you're going to hear that from every HCI vendor on the planet, and you should. All right, so how did hyperconvergence get here? A few people have probably seen a slide like this. I'm not a big fan of build slides, so I just built that out. We talk about this whole stack on the left. We call this the legacy stack, right? So this is your traditional server, SAN switching, SANs, your caching devices, backup appliances, deduplication appliances, cloud gateways, WAN replicators, WAN efficiency devices, all this stuff. And everybody agrees, at least from my perspective in conversations with customers, that managing this is a problem. And so from HCI perspective, everyone says, yes, the data center is too complex to manage, let's simplify it. And what we saw is not just the fact that this is complex to manage, so manage, integrate, implement, lifecycle. You've always got to be evaluating what's the best in breed of each one of these components going forward as you lifecycle them. But then how do I integrate them, and whose responsibility is it once I integrate them? Support handoffs, all that fun stuff. So that's kind of one big complexity problem that we saw. The second problem that we saw as SimpliVity from a founding principle is that managing data between these is inherently inefficient, right? The fact that I've got to move data from a server to a SAN to a backup array to a cloud to a DR facility to restore to copy to clone to do kind of your workflows from a test, dev, QA, production, workflow management, that's all moving data. But it's moving data between disparate devices that were all developed in silos, right? And so SimpliVity, we kind of broadened this and called it the data problem. And so our philosophy was that if we could attack both the complexity problem and the data problem, we could inherently make the data center more simple. That's the whole goal of this thing, is to make the data center simple. Agree with the premise? Agree with the use of the words premise and premises? Fantastic. Awesome. All right, actually, we'll go back. So, first wave of this was we call convergent infrastructure, integrated systems. People kind of call it different things. This is vendor A giving you potentially vendor A, B, and C stuff in a rack, pre-cabled, pre-integrated, management screen, single support call, things like that. Bring it into your data center, power it on, plug it into your network, and go. Great way to consume blocks of infrastructure. Actually, so obviously vBlock is kind of the king of this world. And so one of the things I really like about what they did is they called it a unit of infrastructure. I actually really like that term. Just buy units of infrastructure, units of data center. So a few problems with this. It's still everything on the left, right? Nothing changes from an architecture perspective, just someone else does it for you. That's really about it, right? Someone else supports it, maybe supports it a little better, easier to buy, easier to consume. Everything below the dotted line that's outside of that integrated system or converged infrastructure is still on the end user, the end company, or a managed service provider to build, to integrate. Again, that life cycle, that whole problem from a complexity perspective is still there. And even more importantly, from SimpliVity's perspective, that data problem still exists, right? There's nothing actually unique from a data perspective and a data management perspective happening in those integrated systems. Plus, kind of, and this is my perspective, I don't hear a lot of people talking about this, but I think the unit of infrastructure was too big, right? Just too big of a unit. People don't generally scale. I mean, all right, so some people do. Large enterprises scale $1 million at a time, right? How many of that is your company's, right? It's minimal in the world. So it's just too big of a granularity, if that makes sense. All right, so then we have now this wave of what we now know as hyperconverged infrastructure, which the general premise is let's collapse storage and compute in a hypervisor and scale out node by node, right? Kind of having the principle of just-in-time infrastructure or whatever you want to call it. Some people will call that web scale. Basically, scaling when you need to scale and how you want to scale is generally the idea around hyperconverged infrastructure as we know it today. But again, from our perspective, it still didn't address that core data problem. Plus, there were still other devices that were not converged. Right? We're talking about converged infrastructure or hyperconverged infrastructure. We're trying to converge as much as possible because what does that give us? It gives us ease of manageability, ease of life cycling, ease of support. But really, the more we can converge, the more we can simplify. And so SimpliVity, any guesses how, so most VC-backed companies will be in stealth for about 18 months. Who wants to guess how long SimpliVity took to come out to market? You worked there, you can't say. Anybody who did not work for SimpliVity or HPE SimpliVity in the past, have a guess. The normal is 18 months. We actually spent 3.5 years in development because this is a big problem, right? The data problem, as we call it, is a big, big problem. And so we weren't first to market. That's fine. We were still fairly early in the HCI space. with a couple of others, but we wanted to get it right, if that makes sense. And so what we wanted to do is not have to pass data up and down. We wanted to provide those rich data services in a single platform, managed through a single console by a single admin. And so that's what SimpliVity came out with. So the data virtualization platform is a technology that powers this. And then the HCI product that we came out with, kind of our first iteration, that was a product that sat on top of it to provide that single management screen with a common user interface that people already know. So vCenter. So everybody uses vCenter here. Most people use it across data centers in the world. And so kind of back to that manageability from a kind of a core tenet for us is let's use common tool sets. So most infrastructure admins are used to using vCenter. If they're Hyper-V shop, they're used to using SCCM or Virtual Machine Manager. And so we wanted to plug in directly to that to give users a tool they already know. What that allows us to do is to come in, IT organization, be up and running in about 10 minutes and not have to go through any training. And so not only are we taking away different management screens, so you're not doing that task and context switching all day long, we're also not giving you anything new, so nothing new to learn. So what I found is, for all my deployments so I opened up the Minnesota Dakotas territory as an architect. I did all the deployments myself. And then after all the deployments were done, I would do what's called knowledge transfer, right? Sit down, go through some best practices, SimpliVity 101, how-tos. What I found after about an hour and a half session after deployment, I would go away, say, hey, if you have any questions, give me a call, open up a support case if you want to do a how-to even if you want to. I never got a phone call. I still have yet to get a phone call after an hour and a half knowledge transfer of how do I use the product. It just doesn't happen, which is a testament, I think, to the simplicity of it. I've gotten that feedback from my customers is actually that as a pre-sales architect, I undersell that aspect of the product, which is probably good feedback. All right. Okay to dive deep now? Enough with the marketing stuff? Cool. All right, so how it works. This is a 3-node cluster. Everyone's familiar with how HCI works. I'm not going to bore you with that. Kind of general principles are common across most of them. So we have our data stores, which for VMware is an NFS data store. For VMware, it's an SMB3 presentation. That's just the presentation layer. Then we have our management layer, which is where all the good stuff happens. And so those data stores are just logical presentations out of our management layer. So inside the management layer, we have 2 other sublayers. So our own file system and our own object store, both of which we wrote from the ground up. They are nobody else's. And so in this file system, we have this concept of data containers. So each one of these blocks, we call them a data container. Not to be confused with containers as you probably know them today. We can have an argument over who came up with that phrasing first, but regardless, that's what we call them, and we're sticking to it. So a data container is essentially a map of how do I build a virtual machine. You can call it a map, you can call it a recipe, you can call it a chemical formula. How do I build a virtual machine based on blocks on disk? Right, so we abstract the file system and data containers from the actual blocks on disk. A data container can be one of 2 things. It can be either a virtual machine or a backup, a VM backup. That's it. The lone difference between the 2 is I present a virtual machine up through a construct a hypervisor can understand, or even think long-term, beyond hypervisors, just a storage construct that a bare metal machine can understand. But it doesn't matter, we're just presenting it out of the file system or not. That's the lone difference between a virtual machine and a backup. Again, these are all individual data containers. They're individual maps of how to build blocks on disk. So back to that guaranteed data efficiency thing, one of the things I didn't go through is how deduplication works. I'm sure most people know how deduplication works. I'm not going to bore you with that. So we're not going to write a non-unique I/O. It's not just data, but I/O. And with these data containers, if I will now want to create a clone of this virtual machine, all I have to do is to create, get closer to the clicker, even closer to the receiver. There we go. Just takes time. So all I have to do is to create another data container. It's a brand new data container. It's wholly unique, stands on its own. I can delete virtual machine 1. I can delete all the other data containers. This data container stands on its own. And it's its own map, right? Its own unique block set, or its own unique mapping down to blocks on disk. Now, all I care about are maps and blocks. right? So at the time of VM clone, am I creating any new blocks on disk? Nothing, right? So at the very instant of that clone, there's nothing new on disk. So I avoid all that I/O and all that churn. But this is, again, a wholly unique virtual machine as far as vSphere is concerned. Even as far as our file system is concerned, it only knows that that data container exists as its own unique map. Same thing now when I want to make a backup, say, of virtual machine 3. All I have to do is to create another data container, and I'm done. Now, what I do is I mark this data container as a backup that it came from VM3. Right, that's the only relationship between that data container and that virtual machine data container. Again, I can delete that virtual machine, all of the VMs, all of the data containers, all of the backups before it, all of the backups after it, and that data container remains the same. All our backups, all our data containers are fully immutable, fully air-gapped. Ransomware can never affect that backup because, again, we treat them as completely separate objects. Right? So now if I want to make a restore out of that backup, exact same process. It's actually the exact same lines of code. We create a new data container, map it up to a data store, and I'm done. The longest process is actually with a hypervisor or hypervisor management tool to realize what we've done in the back end. Because to create these, to create a clone, to create a backup, to create a restore is actually just a single I/O for us. Because not only are we deduping blocks, the data blocks on disk, we're actually deduping the metadata trees as well. Right? So we're actually deduping map against map. And so, again, at the time of creation between a clone, a backup, or a restore, from a metadata perspective, they aren't even all that different. So we could spend another half an hour going into the actual metadata tree and how that all works. But essentially, we call it a self-describing metadata, right? So tier 1 means tier 2 means tier 3, and all the metadata that it means. We can go through that. And we're now actually deduping the metadata as well. And that comes into play when we bring this out to the data virtualization platform, again, across the whole cluster. If I want to go forward. All right. So now this is multiple clusters. This is where the data virtualization platform starts to shine. So kind of bringing this back to big picture HPE vision thing is don't think about these now so much as SimpliVity hyper-converged infrastructure silos. Think of these as just a data virtualization platform presented across storage presentations, and whatever that means. Obviously today, these are just 3 separate SimpliVity clusters, wherever we decide to put them. Now, inside each cluster, we're doing the same thing, right? We have our virtual machines, we have our data containers, the blocks on disk. We're only keeping the unique blocks down on disk that we have to, including unique metadata. Now let's say between these disparate sites, I've never sent a backup between them, there's no connection, they're just part of what we call a federation. Real quick, a federation in SimpliVity's terms is any number of nodes connected to any number of vCenters in linked mode, in any sort of cluster configuration. That's what we call a federation. And so these are disparate nodes. They're just connected to the same vCenter or multiple vCenters in link mode. Now let's say I want to send a backup of virtual machine 1 over to data center 2, from Boston to Tokyo. Well, first I just send the map over. And because, kind of back to that metadata conversation with that self-describing metadata, I actually just send the top level of the metadata over, which is just a couple bytes. Right? If I have that top level metadata, like I'm done. Right? I know I have all the metadata beneath it, which means I also have all the blocks beneath it. So what we're doing is we're essentially evaluating what blocks, even what metadata, does that destination not have, and only sending the unique blocks across the WAN. This is even if the sites have never spoken before, right? And so we're doing disparate site-to-site, real-time, global destination-side deduplication, which is a mouthful. But that's what that data virtualization platform gets us. Now again, take this back not just to my production site, to my DR site, but even within a site, dev to production, to QA to UAT testing, all that stuff from a workflow and DevOps lifecycle. Think about this from a cloud archive perspective, pushing the data virtualization platform out to really any storage presentation. Now, think of HPE as a portfolio company and all the different presentations they can give us. And you're kind of getting the idea of like, why did HPE acquire SimpliVity? Was it just for the HCI product? That's a part of it, but this data virtualization platform really were the keys to our castle. Does this make sense? What questions do I have? Yet. I'll keep moving forward. Awesome. So now we take that, and this is what scale looks like from a SimpliVity perspective. A lot of people talk about scaling up within a cluster, scaling out from a cluster, performance-wise, all that stuff. We consider, scale out to mean what do you mean by scale out? So we consider global a scale out. We consider presenting that DVP out to presentations. That's our scale out. We consider, scaling out to a remote site. We also consider scaling compute only. So SimpliVity is one of the only vendors in the market that allow you to scale with compute only. So actually, I'm just configuring a cluster right now with a customer. They've got they're really constrained by their SQL licensing because SQL licenses you based on sockets and cores. Windows licenses you based on now cores. VMware based on sockets. Right? And so what SimpliVity allows you to do is by scaling compute only, we allow you to scale not only more granularly than other HCI products, but in a way that takes licensing into consideration. I can maybe now have just a 2-node cluster with dual 4-core 3.2 gigahertz processors and not have that affect my SQL licensing. That could be a standalone cluster consuming the data virtualization platform.
How does Oracle play into that mix?
And so it plays very, very well. So I actually have some customers who have single socket boxes. So just a standalone ESX host with a single socket CPU consuming the data virtualization platform as a standard standalone NFS data store. And they get all the magic. It still gets all the backup, all the dedupe, all the WAN efficiencies, replication, everything. Any virtual machine running on top of a data store presented out of the data virtualization platform gets all the magic. So I'm going to shorten that whole thing just down to magic, if that's all right. Just shorter than dedupe, blah, 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 blah. Yeah. So from a management perspective, a lot of people will do this with smaller sites or small organizations will have a single vCenter because you have multiple data centers across the world, or you can start to distribute your management domain. So vCenter is in our management plane. It's not in the data plane at all. So vCenter crashes, nothing happens. You could go crazy with your management domains. You could scale this out to as many vCenters as you want. We have as John well knows, we've got a developing and actually now really well-developed REST API set that John has actually been really instrumental for us, so yay, community. Yeah, seriously. It's some things like this, as hard as we pushed internally for a really rich API set, sometimes it can take people from the outside saying, hey, you should have a REST API, and start kicking us, which is great. So thanks for kicking us. So take that REST API, consume anything from a SimpliVity perspective functionality-wise through any tool set that can just use RESTful APIs. PowerShell, Python, ServiceNow, OneView, you kind of name it.
How long has the REST API been available?
It started development, actually Gen 1 was 3.010, which I want to say, when did that come out? A year and a half ago? Is that about right? I think spring of 16. I think we're on V3 of our REST API. Yeah, so great for service providers who have their own tool sets, and again, they don't want to learn anything new. They know APIs back and forward, right? Other questions? All right, so I think the so what is kind of a next logical question. What you can have, this great vision, you can have a great technology, but what are people actually doing with it? What are people actually seeing? So we do a lot of surveys with our customers to actually make sure they are getting business benefit. Because I think if you're not getting business benefit out of your technology, you shouldn't exist. Personal philosophy. So we see that about 81% of our customers are now spending time on new projects rather than reverse. We actually did this with a number of customers, and it was almost an exact reversal. They would say maybe it was like 30% on new projects, 70% on basically keeping the lights on. And for our customers, we've completely reversed that. Right? Actually working on, because managing infrastructure is not that sexy. The business doesn't care about you managing infrastructure. They care about the business. They care about new applications. They care about new services, kind of your really blue chip projects. And that's what our customers are now being able to focus on. From a deployment perspective, a lot of customers they need to move faster, right? And so is SimpliVity helping our customers move faster, time to value, time to business, things like that? And the answer is unequivocally yes, right? From a data protection is a really big reason that a lot of people will choose SimpliVity, and they're seeing this incredible success now in validating their both backup and disaster recovery, how fast they can recover, and actually changing the SLA and SLA conversation within the business, being able to give them SLAs that they never had before, or even didn't think were possible.
Can I ask, I don't know if I'm jumping the gun here, but...
There are no guns.
There are guns.
Not right here. I think Disney says you can't bring them on. You can't bring it on premises.
Integrations with Synergy.
Yes.
I built an architecture for a customer, multiple sites around the world, multiple OmniCube nodes,
Yeah.
and then centralized into a Synergy infrastructure at their home facility, which would in turn not only house the data units that were the backup sort of models.
Kind of a hub or such,
Yeah, it was a spoken hub scenario. Is this type of storage model, which I really think is the differentiator for most hyperconverged platforms, going to be integrated more deeply into Synergy moving forward?
Yeah, that's a great question. And in my mind, I'm trying to figure out how much I can say without getting fired.
Don't want you to get fired.
Yeah, Calvin told me I couldn't do an NDA session. We'll do another NDA session. However, I will say that it's a stated strategy. So the publicly stated strategy of HPE to move the data virtualization platform into the Synergy frame. I can't tell you time frames, but I can tell you it's something that's already in the public, so I can say that, I think.
I think the answer is,
if you email me tomorrow and it bounces, you know what?
yeah. No. I'll take that a step further. The answer is definitely, right? You asked the question, definitely. It's stated direction. Yeah, it's going to happen.
Hey, Rick, Matt's right here. You want to talk to him?
Right. Mr. Lewis. Right.
It's going to happen. It's been done.
It's a huge architecture. I think it's really...
It is. So today I'm using Synergy frames as compute nodes. So I've got a fairly large VDI build out. And they're actually using the NVIDIA GPU sidecars inside the Synergy frame, right? Because it's a CAD shop. So they don't want to have to buy a SimpliVity node just to get more compute. They've got plenty of storage and I/O with the 4 SimpliVity nodes I've put in them, but they need 16 nodes of compute with GPU power. That's a lot of SimpliVity nodes that would just be a waste of money, right? And so we're allowing companies to think about scale differently in an HCI world. All right, so with that, I've got 15 minutes to give the demo, if that's all right. Feel free to ask questions while we go into this. Now it's the plug and pray. Whoever thought we'd be back to plug and pray.
Oh no, what'd you do?
You're funny, Jeffrey.
That's right.
Ba-dum, boom.
All right.
Well played.
Oh.
It's a very thick HDMI cable. Ask, what's the question?
So next audio.
Hold on. I got Jeopardy
While you're
music.
setting that up, can you talk a little bit about if HPE has plans for the platform to support other hypervisors or
Yes. So again, I can't talk about timelines, but absolutely. So the data virtualization platform was built to be hypervisor agnostic. Obviously, everyone runs after vCenter or vSphere first, 800-pound gorilla. So again, can't talk about timelines, but I can tell you that we were on the show floor at Microsoft Ignite, showing Microsoft integration. We will be making some announcements around the Madrid timeframe. And again, that's about as much as I can say without getting fired.
all microservices?
Microservices, meaning like a container, Mesosphere, Docker, Kubernetes. Yes, we actually, again, Yes, yes. So we actually are releasing a solution based around Docker in the not too distant future that you can actually.
No Kubernetes?
What's that?
Docker, no Kubernetes?
Not phase one. Yep. Ooh,
Thank you.
that's jittery as heck. You're welcome. It's jumpy.
And
Well, I apologize for that.
Integration with various cloud platforms.
Yeah, so when we first came to market, we actually had integration to AWS. You could actually spin up an AMI of our virtual controller and just send backups up there, right? Really efficient to send data up.
Still chunky.
Right here. Yes, so what we found is, so customers that deployed that, is they were coming back with us that it's, even though we're efficient with it, it's still costing them a fair amount. We talked about this a little bit over Twitter. There's the if versus actual of cloud costs, right? And so what they found is over a 3-year period, is actually cheaper to buy more SimpliVity infrastructure and throw in a colo and manage it themselves than putting it out on Amazon.
Do you have documentation on that? Because I'd really like to
Yeah,
leverage
so
it.
because of that, we actually depreciated it until cloud costs came back in line with what we could provide them for on-prem. And so it's coming back. It's 100% coming back. I don't know if it's going to be AWS again as the first gen. I'll say HPE and Microsoft have a very close relationship, and you can infer things. Apologize for the jittiness, so hopefully we can get this while we go on. All right, so this is our management interface. Then full stop, we talked about this. Backup policies, I spend a little bit of time on because, again, this is a pretty big differentiator from us from an HCI product perspective, is this integrated data protection, resiliency, all this fun stuff. And so each of these backup policies, you can think of them like SLAs, right? Every virtual machine is treated differently if you wanted to. I know every application owner thinks their application is a unique butterfly and should be protected as such. But you can create these policies based on the SLA of the VMs. You have your tier 1, tier 2, tier 3 VMs, create the policies that match. A policy itself is made up of a bunch of rules. And the rules are fairly simple. So if we come in here to create a new rule, a rule simply states how often do I back up, how long do I keep that backup, and where do I keep that backup. So now just think of this as a list of resources, a list of storage presentations, right? And that's essentially what's always going to be for us, just a list of something being abstracted, right? And so that's a single rule. Rules roll up to make a policy. So in this rule, in my daily bronze daily backup policies, say I've got daily backups kept for a month, weekly backups kept for 3 months, and backups on the last day of the month kept for 2 years. All right, so I apply this policy to a virtual machine that matches this SLA. You can apply it to a virtual machine, groups of virtual machines, or at the data store level as well. So any virtual machine that gets created in that data store automatically inherits that policy.
Can you use vSphere tags?
So not natively within the interface today, but you can through the API, absolutely. Yep. All right, so we'll go to the cluster level. Again, our idea is global management. So we'll look at the Cleveland cluster, which is our production cluster here. We'll go to the monitor tab and the SimpliVity capacity. So what you're going to see here is this is the view into that data virtualization platform and data containers within the Cleveland cluster. So specifically just that Cleveland cluster. So on the left-hand side, see 18.8 terabytes of VM data. That's all our VMDKs added up. 398 terabytes of local backups and 142 terabytes of remote backups. That's backups from Philadelphia coming into Cleveland. So all in all, I have 560 terabytes of data logically stored within this cluster. And again, if you think back to that data containers perspective, because we treat every data container as fully unique and fully separate within the file system, if you extracted every single data container separately and individually, this is what it would consume. Because we have no other view of it, right? We see every data container as fully unique. And so if you pull this off onto a backup system, a tape system, another storage array that wasn't doing data efficiency, it would consume 560 terabytes. So because of that inline data efficiency, so not just production I/O, but now the backups and clones and copies and restores, I've only ever used 5.8 terabytes on disk within the cluster. But more importantly, think about this from an I/O perspective. It's not just 554 terabytes of capacity savings, which is, whiz bang, wow, cool. But it's 554 terabytes of I/O that never happened. All right, so we'd like to talk about, and I forget who it was. It was some secondary storage vendor or backup vendor that did a study with IDC. It's about 80% of today's storage costs and storage capacities. It's secondary storage. Backups, copies, clones, DR, replication, that's all secondary storage, but it's also all secondary I/O. It's all cascading I/O from production. And in our world, the data virtualization platform was built to avoid all that cascading I/O. And so that's what this means. And then we get to look into the performance of the cluster. Again, this is just localized within this cluster. This is kind of fun because this is a shared system between architects, so I kind of never know what I'm going to see here. Someone could be doing something incredibly stupid, like, I don't know, running something here. So this is something abnormal that somebody did. I have different views and different granularities, and if I want to, we go back and look at this open top contributors, see what virtual machine was generating this I/O. All right, so somebody was logged into this VM at 11:20 a.m. to generate this kind of I/O. Right, so real quick visibility into who's doing what. So now if we go into some actual VM operations, this is where the rubber really meets the road. I've got a whole bunch of VMs. I'm going to choose this VM to pick on. So it's 488 gigs inside the virtual machine. So I'm going to right-click. You see all the SimpliVity actions here. Again, full integration into the vSphere client for ease of operation. And make a clone. You'll notice here that this interface is actually HTML5. We are getting ready for the vSphere HTML5 client. So we're rebuilding most of our interfaces already for that. We'll give it a name so I can see it at the top of the list. Quick. Hit next and finish. I can do a crash consistent or application consistent clone. We can actually, at least today, reach into SQL and quiesce the database before we take our clone. Now it's not going to truncate the logs, but it is going to flush all incoming writes and commit them before we make that clone. So we can do that on a per VM basis. So the clone itself is done. So you can see that operation took an entire 6 seconds. To create a brand new clone, I got to do a little refresh action. Come back to my federation. Oh, it's already there. So here's my VM. All 488 gigs of it. So HA sync, we're actually now verifying. So we write data. This is what we didn't cover from an architecture perspective, but we write data simultaneously, synchronously between two nodes. And so when we create a clone, we verify that everything created successfully across both nodes. So you'll see an error for about 30 seconds or so. But now I'm going to take a backup of this VM. So right click, do a backup. I can give it a name. By default, it's going to give it a -backup -timestamp. So I don't have to give it a designated name. From a destination perspective, this is just like in my rules, where I'm saying, where do I send this backup? Same thing here. I'm going to send this offsite to the Philadelphia cluster. And hit OK. Again, we can see the tasks down below. Those are all standard vSphere tasks. So think about alarms, alerts, auditing, logging. That's all in vCenter. I'm going to take another local backup, or I'm going to take a local backup, because I want to spend a couple seconds talking about this destination cluster list, which I'm sure this is maddening for you guys to look at. It's fine on my computer. Don't worry. I'm good. Right. It's all about me. So if you notice, it's just cluster names, right? So I'm looking at the data centers and clusters. I abstract all the underlying infrastructure from the cluster level. So data stores, number of hosts, number of nodes, I don't care, right? And second thing is, so who's set up something like SRM or Zerto or something where it's nothing against you, Justin, at all. Zerto is great, but it takes configuration, right? When you're first setting up a DR software, DR suite, whether it's SAN replication, anything else, you've got to deploy some resources, configure the resources, configure the targets, configure the destinations, configure your runbooks, all this different stuff. And if anything changes within the infrastructure, I add nodes, I add hosts, I add data stores, I remove data stores, I've got to go back in and make some reconfigurations. In SimpliVity's world, none of that exists. So if I deploy a third node at a third site down here, it would automatically populate in this list. So setup for replication in DR doesn't actually happen from a user perspective. We take care of that on the back end. Again, the idea is simplicity. So if I add nodes, add hosts, add data stores, I don't care. I'm going to take a local backup. And if we go look at this virtual machines, SimpliVity backups, you notice we moved really quickly. We now already have the HPE branding. So go marketing and engineering. So here are my two backups for this virtual machine. This top backup is from the Philadelphia cluster. The sent size, the size of the VM is 488 gigs, but the sent size is 31 megs. Right, so even though this is a brand new virtual machine, I created the full clone of it, sent it off to a disparate cluster. I did a full destination side deduplication check and only had to send 31 megs. So that's the entirety of the difference between this virtual machine and the blocks on disk at the destination. And we give you a timestamp on how long it took and all that stuff so you can audit all this stuff. So now let's say we want to do a restore. We can right click any backup, restore the whole VM. We can restore it back to its original location. We can restore it across data centers if you like. We can do an in-place restore. So let's say you did get CryptoLocker and you just want the virtual machine back right effing now. You hit this button. So for that reason, we don't check that by default. We should call it the right effing now button. That's what I think. But it's also why I'm not in marketing. Many reasons why I'm not in marketing. Sorry, Brian Knutson. All right, so let's say, actually I'm going to power on this VM because I do want to show some more granularity of recovery. All right, so you can see the recovery itself took, again, all of 4 seconds to get a full virtual machine back. Again, it doesn't matter if that virtual machine's been deleted. If it were deleted 6 months ago, it would still take that much time. And it doesn't matter the size of the virtual machine. So backup, copies, clones, restores, it doesn't matter if it's a 5 gig virtual machine or a 5 terabyte virtual machine. It's going to take the same amount of time. And we actually have that in our warranty. All right, so that virtual machine I think is probably powered on now. So let's actually do some restore files, which is a simple wizard-driven interface. It's kind of next, next, next. We see our VM decays. We'll expand these out. And this NTFS partition, pretty easily enumeratable. Is that a word? Somebody check me. Enumeratable. Able to be enumerated. We're okay making things up, right? That's fine.
Works.
All right, so here are the individual files I want to recover, or I can recover an entire directory. We're going to restore the directory structure intact. Choose the VM to restore to. I could choose a different VM. I could choose a VM across at a different cluster if I wanted to, but I'm going to choose the original because I just powered that on. I see my target, source, destination, all that fun stuff. I hit finish, and I'm going to RDP into this VM. It's on. Yep. 10:35. Oop. No one told me I mistyped that. Come on. You guys are slacking. Man, typing in front of people, you always mistype things, right? Yep. All right, so here is the virtual machine. I'm going to open up my directory. Actually, we'll just go to this PC. And we'll see actually I have an ISO mounted with the directory structure intact. So that directory I only chose 2 files. This directory, I chose the whole thing. So now I can just drag and drop these back to wherever they need to go. So the reason we present it as an ISO image, it's a few reasons. One, it doesn't consume any more space inside the virtual machine. So let's say you're restoring 10 gigs of data back to the VM doesn't have that kind of capacity, or you don't want to wait to do that. We just pop in the ISO and you're done. There's 0 chance of accidental overwrite. Right? You cannot overwrite the destination files unless you drag them back to the destination and say, yes, overwrite them. Now, there are cons to that. I can't just do it from the interface and say overwrite them. So we made decisions. There's trade-offs for everything, but that's why we made the decisions we did. All right, so that is file level recovery. Let's actually look at some of the data store usage. It's kind of the last thing I want to show. So data stores. Traditional SAN environment, I realize many SANs are getting better. Everyone's kind of got a vSphere plugin today to make data store creation a little bit easier. But still on the back end, it's creating a LUN, presenting it through some sort of protocol, whether that's an IQN or rolled by names and some SAN fabric. Then you're mounting with VM, mounting the LUN, formatting with VMFS, and now you're ready for VMs to live on there. For me, I hit new data store. I choose the cluster to restore to. Again, this is a global system. If I've got 30, 40, 50 sites, I just want to say deploy this data store in that cluster. I don't care. So I'm going to do this in the Cleveland cluster. So mat data store, I give it a default backup policy. Again, so any virtual machine that gets created in this data store automatically inherits this policy. We give it a size. We hit OK. Again, you're never leaving the vCenter interface. And we see all the standard vSphere tasks down below. And now I have my 1 terabyte data store. So vSphere is going to honor that size limit, right? VMware only understands VMDKs and data stores. So it's going to say if you've got 1 terabytes of VMDKs filled up, no more space for you, no soup. So we need to on that resize. Let's go crazy. Let's make it a petabyte just because I can. Now I've got a petabyte data store. Maybe that was a fat finger. Not that you've ever mistyped anything in your infrastructure before, but I do. So let's make this now 10 terabytes. Don't try this on your SAN at home. It probably won't like it. Now I have a 10 terabytes data store. Now let's say I want to scale granularly. I've got plenty of capacity, plenty of I/O, but I just need more CPU and RAM. Again, very common in VDI environments or high-performance compute environments. That's actually manage a standard ESXi host. This would be, you can see our blades, you can see our Synergy infrastructure. Any node in this cluster, I just check the box. I have an HPE BL460. I hit OK, and I've just scaled compute with a checkbox. And that's it. That's the entirety of a SimpliVity infrastructure.
Does it do thin provisioning?
Yes, we only have a concept of thin. So you can specify to be thick provision and even eager 0 thick. But if you think about what that's doing, it's just writing down a bunch of zeros. In a fully deduplicated and compressed environment, we're going to take all those zeros and not write them. But the CPU and the host still has to go through the process of writing it. So it's just going to take, you're just wasting time is all you're doing. Because even from an I/O perspective, we're taking all random I/O and we're serializing it before it writes it down to the disk set. Right? So we're actually starting to remove that I/O blender effect that Mr. Foskett loves to talk about from the virtualized environment.